Good evening, everyone. So, welcome to my YouTube channel, Master. So, today we are going to see second lecture on convex function. Today we are going to see an important question, or you can say result, that if you have a convex function on an interval, then local point of minimum is nothing but absolute minimum. Okay, point of minimum. Let's see. So, theorem, I am asking. Let I be a non-empty interval, okay, on R, and f I to R be a convex function. Convex function. Then so you simply write here it is interval, okay. So I is subset of R, obviously, and f I to R be a convex function if if x naught belongs to I is a point of local minimum for f, then x naught is actually a point of absolute minimum for f. Okay. Let's see its proof, how we will do it. Let let f let x belongs to I be a point of local minimum for f. Okay. Then there exists a delta greater than 0 such that x naught minus delta, x naught plus delta open interval containing I and f x naught is less than f y for all y belongs to this interval. Okay. Now take x belongs to I. Okay. Take x belongs to I. Or in place of in place of y, you can write x there. X. Take x belongs to n. I put xn is equal to xn is equal to 1 minus 1 upon n x naught plus 1 upon n xn. Okay. Then this requires xn stands to x naught as n tending to infinity. So this implies there exists a capital N belongs to n such that xn belongs to x naught minus delta x naught plus delta for all n belongs to n greater than or equal to capital. Now xn is equal to, what is this? This is 1 minus 1 upon n x naught plus 1 upon n x. So by convexity, this is less than 1 minus 1 upon n f x naught plus 1 upon, because f is a convex function. Okay. So this implies f xn is less than okay. Okay. So we reach up to this one. One minus one upon n f x naught plus one upon n f x. Let's say this is equation number. Now next xn belongs to I x x naught minus delta f naught plus delta. Okay. This belongs to this one. Okay. So from star, so what is the star equation? We are calling this as a star equation. So from star, what we have? From star, we have f x naught will be less than f x n. Okay. So let's say this equation number 2. Now from 1 and 2, what we have? So this is true for all n greater than capital N. Okay, because here we have n greater than capital N. Now from star we have this one. So from 1 and 2, from 1 and 2, from 1 and 2, we get from 2 what we have this one, fxn less greater than fx naught. And from 1 what we have 1 minus 1 upon n fx naught plus 1 upon n f xn, sorry, fx, we have this one. Okay, so finally what we have, for all n greater than capital N. So combining these two parts, what we have fx naught less than 1 minus 1 upon n fx naught plus 1 upon n fx, for all n greater than capital N. Okay, so this implies fx naught. Now open this bracket. What is this? Fx naught minus 1 upon n fx naught plus 1 upon n fx. So what is this? This is cancel out. So we go to this one. Now this is cancel out. This is cancel out. So what we got? We got fx naught is less than fx. Okay. Since x belongs to I is arbitrary, we have fx naught less than fx for all x belongs to I. So this implies this implies x naught is a point of absolute minimum for x. Okay. So this is done. So this is proof. So today's lecture of today, if you have any problem related to this, you can comment on my YouTube channel. Like, share, comment and subscribe my YouTube channel. So thank you very much for today's question. Thank you very much.